Hi everyone. G star is an abelian group of order 6. 4 of the elements in the group are E, X, Y, and XY squared, where E is the identity element and XY squared equals X star Y. Given that the element X has order 2 and Y has order 3, we're going to write down the missing 2 elements of the group. And then we're going to also answer these 2 questions here. We're going to show that these are equal and explain why our group is cyclic. So basically, for the first one, let's write down our group G. And we know we have E, X, Y, and XY squared, where E is the identity element, and we need 2 groups. Now, given the information that we have, X star X has order 2. That means this equals your identity element. And Y star Y equals Y cubed, which also equals your identity element. Since this is a abelian group, we know it's a group, so we know that every element has its own inverse. So what you're going to do is we have these 2 here. So we're going to write X squared, Y cubed. We know this is going to be E star E. We can put stars here if you want. This equals your E. So what we're going to do is look at the other elements. So we want this to equal, for example, let's look at this one, XY squared. So basically we have X star X star Y star Y equals, this should be star, X star Y star Y. So if we want this to equal E as well, then what we need is another Y and another X. So what we need is a XY. All right, so we can set these equal to each other. Now, the next one, we're going to have a X star Y star, and we're going to set this to equal, this is cube, to our, let's do X. So we know this part here equals E. So to get this, what we'd have to multiply this by is X, I'll do it in a different color, X star Y squared. So these 2 equal. But we already have that, so we don't need to add that to the group. Now let's try the next one, X squared star Y cubed equals Y. So to get this is cube. To get this, you would star this Y by Y squared and also star this by X squared. So you get X squared star Y cubed. But in this case, this is E. All right, and this is Y cubed here is also E, but this one, we just need Y squared. So we need a Y squared to get, to manage with this Y. But remember, this is just E, so we can cross that out. So the only thing we need to match this up, because these 2 kind of like cancel, is another Y squared. So those are the 2 missing elements. Now we're going to go on to B. So for B, we have x cubed y to the fourth. And let's break this down. This equals x squared x, y cubed y. So we already know this is ex, and this is y cubed. Whoops. Sorry about this. So this is going to be ex, ey. And this equals xy, which also equals yx. So there's that part. And C, we want to explain why our group is cyclic. So what we have to look at is this order 6. So we're going to take our xy squared to the 6th power, and that's going to give you x to the 6th y squared, y to the 12th, and that's because it's commutative. Because it's given that it's an abelian group. All right, then I can break this up as x squared cubed, y cubed to the 4th, and then this is going to be e cubed, y cubed, e to the 4th, which equals e. So that means this element that's in our group has the same order as our group. So in the element of the element is 6, this order is 6. That means the order in the order of the group also is 6. That means it's cyclic or cyclic. Okay, and it wouldn't have worked for any other elements. And that's it. Thank you. Have a nice day. Bye-bye.